Imagine you are floating, not the gentle, warm floating of a dream, not the peaceful weightlessness of a pool on a summer afternoon. This is the floating of the void, the kind that happens when there is no ground beneath you, no air around you, no warmth anywhere in any direction, and the closest human being to you is so far away that their radio signal will take longer to reach you than it takes a child to learn to walk. Imagine you are floating, and you are looking at it. At first, your brain reaches for beauty. You have been trained to see beauty in the cosmos, the Hubble deep fields, the pillars of creation, the swirls of distant galaxies. So when you see it hanging in the darkness against a spray of stars you have never seen from Earth, your brain reaches for awe. It does not find it. What it finds instead is something older, something that lives below language, below thought, below reason. The feeling that something is terribly, fundamentally wrong, because this planet is not like anything you have ever seen. It is larger than Jupiter by a margin that makes Jupiter look like a child's marble. Its surface, if you can call it that, is not a surface at all. It is a churning ocean of superheated plasma and metallic hydrogen extending downward for tens of thousands of kilometers without ever reaching anything solid. The colors are wrong, not aesthetically wrong. Wrong in the way that makes your reptile brain scream at you to turn around and find somewhere, anywhere, that does not look like this. The clouds are the color of an old bruise. They move at speeds that make Earth's worst hurricanes look like afternoon breezes, wind speeds exceeding 2,000 kilometers per hour, sustained, constant, unrelenting. Winds that have been blowing since before the first fish crawled out of the ocean and will still be blowing long after the last human being draws their last breath. And the temperature. The temperature on the day side of this planet exceeds 4,000 degrees Celsius. That is hotter than the surface of most stars, hot enough to vaporize iron, hot enough to turn rock into gas, hot enough to make the concept of a spacesuit, any spacesuit, any material science we have or could conceivably develop, into a dark joke. But the night side is not better. The winds carry heat from the day side to the night side, creating temperature differentials so extreme that the atmosphere itself becomes a weapon. On the night side, those superheated gases cool, not to anything survivable, but cool enough to condense. And what condenses on the night side of this planet is not water vapor. It is not ice. It is iron. It rains iron on this planet. Molten iron droplets falling from clouds made of vaporized metal, landing on a surface that is already composed of things that should not exist in any configuration a human being could survive. This is HD 189733b, and it is, by every measurable standard we have, the most hostile world ever discovered. Welcome back. Before we talk about what this planet would do to you, we need to talk about where it is. The distance is the first horror, not the iron rain, not the 4,000-degree atmosphere, not the planetary scale winds. The simple, stark, mathematically indifferent fact of how far away it is. HD 189733b orbits a star in the constellation Vulpecula, the Little Fox. Romantic name. The distance is not romantic. The distance is 63 light-years from Earth. 63 light-years. A light year is the distance light travels in 1 year. Light moves at 299,792 kilometers per second. In 1 second, it crosses the Earth's equator more than 7 times. In 1 year, it travels 9.46 trillion kilometers. 63 light-years is 596 trillion kilometers. The fastest spacecraft humanity has ever built is the Parker Solar Probe, achieving roughly 692,000 kilometers per hour at its closest solar approach. Let's pretend you could hold that speed constantly, forever. At that rate, reaching HD 189733b would take approximately 98,000 years. Not 98 years, 98,000 years. The cave paintings at Lascaux are 17,000 years old. To reach this planet at our fastest speed, you would need to have departed 6 times further back in history than that, at a time when Homo sapiens had not yet left Africa, when Neanderthals still walked the earth, when every empire, every language, every piece of music ever written had not happened yet, and would not happen for thousands of years. That is how long it would take. You might say that we will develop faster propulsion. You are right that technology will improve, but the fastest speed any known propulsion system could theoretically achieve, fusion drives, antimatter engines, laser-pushed solar sails, sits around 10 to 20% of light speed. Theoretical, unbuilt, perhaps never buildable at scale. At 10% of light speed, the journey takes 630 years, more than 6 centuries, further into the future than Shakespeare is in the past. At our actual current speed, 98,000 years. But let's say, for the sake of understanding what we are dealing with, that you found a way. A ship that makes the journey in a human lifetime, 30 years. You are 25 when you leave. You are 55 when you arrive. What happens to your body on that journey? The moment your ship leaves Earth's protective magnetic field, you enter an environment that is trying to kill you. Quietly, patiently, without malice, because the universe does not have malice. It has physics, which is worse because you cannot negotiate with physics. The first threat is cosmic radiation, not the kind from nuclear power plants or X-ray machines. Those are manageable. Cosmic radiation comes from everywhere: solar wind, galactic cosmic rays, high-energy particles accelerated to near light speed by supernovas and pulsars, and it passes through almost everything. On Earth's surface, you receive roughly 2.4 millisieverts of radiation per year. Safe. Background. Normal. In deep space, that number rises to 400 to 900 millisieverts per year, between 167 and 375 times the surface dose. NASA's lifetime career limit for astronauts is 600 to 1,200 millisieverts. You would exceed your entire career limit in year 1. Over 30 years, you accumulate 12,000 to 27,000 millisieverts. Radiation damages DNA constantly. Your cells have repair mechanisms and they work hard. But at these doses, the rate of damage exceeds the rate of repair. Errors accumulate. High-energy heavy nuclei, called HZE particles, punch through your cells like bullets, leaving trails of damage your repair systems were never evolved to handle. Because for the entire history of life on Earth, nothing lived in deep space. Nothing needed to evolve resistance to this. The cancer risk escalates dramatically. But cancer is almost secondary because HZE particles also damage your brain. Studies on mice exposed to equivalent radiation levels show reduced cognitive function, impaired memory, anxiety, depression, disruption of the hippocampus. In human terms, after enough years in deep space, you become measurably less than what you were. Not obviously, not overnight, gradually, irreversibly. The person who arrives at the destination 30 years later will not have the same mind as the person who left Earth. While radiation does this to you, microgravity does its own quiet work. Your body evolved in gravity. Every system, cardiovascular, skeletal, immune, was shaped by billions of years in a gravitational environment. Remove that gravity, and the body interprets signals incorrectly. Your bones. Mechanical stress is what drives bone-building cells to build. Remove the stress, and those cells slow down. But the cells that break bone down do not slow down. Bone density drops at 1 to 2% per month. In 6 months, 6 to 12%. In a year, 12 to 24%. The lower spine and hip are most vulnerable, the regions you need most if you ever want to stand again. Your muscles, postural muscles, back, legs, core, atrophy without the constant demand of carrying weight. Astronauts on 6-month ISS missions lose 20 to 30% of muscle mass in certain groups despite exercising 2 hours every single day. Not laziness. Biology. Your heart. In microgravity, it does not need to work as hard. It changes shape, becomes more spherical. Its mass decreases. After decades, whether it could readapt to gravity at all is an open question. Your vision. This may be the most alarming finding of the last decade of space medicine. Intracranial pressure increases in microgravity. The optic nerve is sensitive to that pressure. Long-duration astronauts return with deformed optic discs, flattened eyeballs, folds in the retina, and visual degradation that does not fully reverse. 60% of long-duration astronauts experience some visual impairment. It is one of the most urgent unsolved problems in human spaceflight. Your immune system becomes dysregulated. Latent viruses that were suppressed, herpes family viruses, Epstein-Barr, varicella zoster, begin to reactivate. Natural killer cells become less effective. The immune response turns aberrant, sometimes underreacting to real threats, sometimes overreacting and causing inflammation in your own tissues. Your body, without the constant microbial challenges of Earth's environment, begins to lose calibration. The immune memory built over a lifetime of exposure to Earth's pathogens gradually becomes irrelevant, while the new challenge, keeping dormant viruses from erupting, strains the system continuously. After 30 years, you carry a body that is structurally compromised, neurologically impaired, visually degraded, and immunologically weakened, saturated with decades of radiation damage accumulated in silence, one particle at a time. And all of this happens before you arrive. Then there are the 30 years themselves. Your ship, even a generously imagined ship, large by any standard of engineering we can currently conceive, is smaller than a city block. Probably smaller than a large house. You share this space with a small crew, perhaps 6 people, perhaps 8. These are the only human beings you will see, touch, or speak with directly for 3 decades. Not months, not years, decades. Think about the people in your life right now, the handful you are closest to. Imagine being confined with only those people, no one else, ever, for 30 years. No new faces, no strangers, no chance encounters, no one to complain to who is not also a subject of your complaints. No privacy beyond what a thin wall and a shared agreement to pretend provides. Every conflict festers in an enclosed space with nowhere to go and no one else to talk to. Communication with Earth is severed not by technology but by physics. At 63 light years, a radio signal takes 63 years to make the round trip. If you sent a message the day you departed, the reply would arrive 6 years after you had already reached your destination, if the reply came at all, and if whoever sent it was still alive, and if Earth's civilization had not changed so dramatically that the reply was incomprehensible. There is no mission control, no real-time guidance, no one to call in a crisis. By the time any distress signal reached Earth, whatever emergency you faced would have resolved itself, one way or another, long ago. This is a level of isolation that has no precedent in human experience. Antarctic researchers winter over in small groups for 6 to 8 months, and the psychological literature on those stations is sobering. Depression, anxiety, cognitive impairment, interpersonal conflict that would be trivial in normal circumstances but becomes catastrophic in confinement. These appear reliably, even in carefully selected and trained individuals. At 6 months, these effects are manageable. At 12 months, they become serious. At 30 years, they exist in a regime we have no data for because no human being has ever endured it. Sleep disorders, chronic low-grade depression, the slow erosion of motivation, the strange grief of watching Earth recede not just in distance, but in relevance, knowing that the world you left is continuing without you, changing without you, forgetting you in the way that living things eventually forget what is absent long enough. You are more alone than any human being has ever been, more alone than any castaway or polar explorer or prisoner, because all of those people existed within a web of human civilization that, however thinly, still extended to their location. Rescue was theoretically possible. Communication was theoretically possible. The world knew where they were. You do not have that. You are a small spark of biology crossing a universe that does not know you exist, headed toward a destination that would kill you the moment you arrived, in a body that is no longer the body that left Earth. And you cannot simply turn around. The return journey, if you attempt it mid-mission, uses provisions calculated for one direction. Your bodies are already damaged. Turning back means 30 more years of the same damage in reverse, with half your supplies, in a ship that has now been running continuously for however many years you traveled before deciding to quit. The trap closed the moment you cross the magnetopause. The universe is not moved by courage. It is moved by nothing because it feels nothing. Let's say you survived the journey. Let's say through some extraordinary combination of medicine and technology and resilience, you arrive at the HD 189733 system 30 years later. Crew still functional, still thinking, still capable. You are in orbit around HD 189733b. What are you looking at? HD 189733b is a hot Jupiter, a gas giant roughly 13% larger than Jupiter, about 1.13 times its mass. It orbits its host star at a distance of 0.031 astronomical units. Mercury, the closest planet to our Sun, orbits at 0.387 astronomical units. This planet is more than 12 times closer to its star than Mercury is to ours. It completes a full orbit in 2.2 Earth days. The gravitational tidal forces have locked it permanently, one face in eternal daylight, one in eternal night. The day side reaches roughly 1,200 degrees Celsius at the cloud tops. Deeper in the atmosphere, temperatures climb to 4,000, 5,000, 6,000 degrees. The night side sits at around 900 degrees Celsius, hotter than the melting point of gold, hotter than the hottest lava ever recorded on Earth. The cold side of this planet would vaporize most materials within seconds. But temperature alone does not capture what makes this planet specifically, precisely terrible. The iron rain. The day side is so hot that iron vaporizes. It becomes gas. Convection currents carry it into the upper atmosphere. The 2,000 km/h winds, those rivers of superheated gas flowing constantly from day to night side, carry the iron vapor toward the cooler night side. There, it condenses into droplets, and those droplets fall. Molten iron, raining from clouds made of vaporized metal. Deeper in the atmosphere, the temperature rises again. The iron revaporizes. Convection carries it back up. The winds carry it back to the day side. The cycle repeats, eternally. A weather system that runs on iron sustained by temperatures and pressures our civilization has only encountered inside nuclear reactors and particle accelerators. HD 189733b may also host silicate clouds, clouds of vaporized rock minerals condensed into particles at certain altitudes, glass clouds. Flying through them at 2,000 km/h, those silicate particles would pass through any conceivable material, like bullets through paper. And then there is the color. Astronomers measured it using the Hubble Space Telescope. HD 189733b is blue, a deep, vivid cobalt blue, caused by silicate particles scattering blue light in the upper atmosphere. It is the most deceptive color in the universe. Earth is also blue, seen from space. Our blue means water, life, possibility. HD 189733b's blue means superheated glass particles in an atmosphere of vaporized metal driven by winds faster than the speed of sound. The most beautiful and the most dangerous color in the known galaxy. The same shade, different everything. You are in orbit. You decide, against every signal your body is sending, to descend. The first problem is that there is nothing to descend to. HD 189733b is a gas giant. There is no surface. As you descend, the gas grows denser. The pressure increases exponentially. The temperature climbs with every kilometer. There is no moment of touchdown, no horizon resolving into ground. What there is instead is a process of obliteration. Titanium melts at 1,668 degrees Celsius. The dayside upper atmosphere is already at 1,200 degrees. The temperature climbs as you go deeper. Tungsten, the metal with the highest known melting point, melts at 3,422 degrees. The planet's interior exceeds that. No material we can manufacture or theoretically conceive can simultaneously withstand pressures of millions of atmospheres and temperatures of thousands of degrees. The winds alone would destroy any extended hardware within seconds. At 2,000 km/h, carrying iron droplets and silicate particles, the wind is not a force to be deflected. It is an erasure. The radiation from the host star, at 360 times Earth's solar exposure, continuously erodes the planet's upper atmosphere. Any spacecraft in close orbit would be similarly eroded, and none of this accounts for what has happened to you. 30 years in space. Your bones are compromised. Your vision is degraded. Your immune system is dysregulated. Your cardiovascular system has adapted to the absence of gravity. And HD 189733b's gravitational pull is 2.3 times Earth's. A person who weighs 70 kilograms on Earth would weigh 161 kilograms here. A heart remodeled by decades of microgravity, asked to pump blood against 2.3 times the load. Leg muscles that lost 30% of their mass, asked to carry twice the weight. Walking would be agonizing. Standing might be impossible. The cruelty of physics is this: the journey long enough to be theoretically possible is also long enough to make the human body incapable of completing it. A shorter journey requires a faster ship, which we cannot build, a closer destination, which this is not. Every variable in the equation leads to the same place. It is a trap within a trap. Let's run the full scenario. Year 0. You are 25. Peak condition. Selected from tens of thousands. Your bones are dense, your muscles strong, your vision perfect, your mind sharp. You leave Earth. The moment you cross the magnetopause, 70,000 kilometers from Earth, the radiation environment changes permanently. You feel nothing. Cosmic radiation is invisible, silent. It just accumulates. Year 1. 600 millisieverts accumulated, roughly NASA's lifetime career limit for a low-risk astronaut. Your bone density has begun to fall. Muscle mass in postural groups is down 10 to 15% despite 2 hours of daily exercise. Early signs of intracranial pressure in your vision. Your immune system is beginning to lose control of dormant viruses. You feel like yourself, but you are already not the person who left. Year 5. 2,500 millisieverts accumulated, measurable cognitive changes, reaction time slower, working memory reduced, bone density down 15 to 20% in weight-bearing regions. You have not seen natural light, felt wind, heard birdsong, or seen a new face in 5 years. 5 years. Year 10. 6,000 millisieverts. A decade in space. Your heart has changed shape. Your optic discs have been compressed. Your visual acuity is measurably worse. Your bone density in the lumbar spine and hip has dropped 25 to 30%. You have 20 more years to go. Year 15. 40 years old. You are halfway through. You cannot go back. Going back is now worse than going forward. You have already absorbed half the radiation dose, suffered half the bone loss and cardiovascular remodeling. The argument for return has been lost by arithmetic. The trap has fully closed. 15 years of recycled water, every glass filtered from someone else's sweat and urine and your own, passing through membranes and UV chambers and chemistry you cannot taste but know is there. 15 years of recycled air produced by machines, CO2 scrubbed, oxygen replenished, the same molecules cycling through your lungs and your crewmate's lungs in an endless loop that never opens to a sky. 15 years without a horizon, without rain, without earth under your feet, without a smell that wasn't manufactured or human. 15 years of the same faces, the same compartments, the same sounds of the same machinery, the same darkness outside every viewport, not quite the same stars, the parallax shifting so slowly as to be imperceptible, but effectively, utterly the same darkness. And the knowledge that your radio signals take 63 years to make the round trip, that whatever message you send home tonight will be read, if anyone reads it at all, by people who were not yet born when you departed, that the people you knew and loved on Earth are growing older in ways you cannot see, dying in moments you will never know about until decades after the fact, if ever. You are not just separated from Earth by distance. You are separated from the present tense of everything you were, your crew. In 15 years, you have had conflicts you could not resolve because there is nowhere to go and no one else to turn to. You have formed bonds that go deeper than most marriages because you have no choice. Intimacy is not optional when you are 8 people in a sealed environment for 15 years. And you have watched crewmates struggle with depression that settled in so gradually it was impossible to date its beginning, with cognitive changes subtle enough to deny but real enough to affect decisions, with the slow, quiet grief of understanding that the person they were when they left Earth is not quite the person they are now. You have perhaps watched a crewmate die from illness, from accident, from compounding medical emergencies that here must be handled with what your ship carries, which is extraordinary by any terrestrial standard, but is still finite, still limited, still 63 light-years from the infrastructure that trained you to treat these things as solvable. Year 20. 12,000 millisieverts accumulated. Clinical cancer risk is no longer statistical. It is likely some of your crew are probably dealing with radiation-induced malignancies right now, being treated with the finite resources of your ship. Your cognitive function has declined measurably. The navigational calculations done in year 20 are done by a mind that is not as sharp as the one that left Earth. Decisions are slower. The safety margins in medicine, in navigation, in engineering are thinner than they were, and they were never as thick as you wished. Year 25, 50 years old, 10 years left. Every day is identical. The stars outside have not shifted perceptibly. Space does not look different as you move through it. Space just looks like space, the same in every direction, from everywhere, forever. There is no landscape, no change of scene, no weather you did not manufacture, no day or night except the rhythm your ship imposes by scheduling. Year 30, 55 years old, in orbit around HD 189733b. You cannot land. You have traveled 30 years to look at a planet you cannot touch. 30 years of radiation, 30 years of bone loss, 30 years of isolation, 30 years of recycled everything, 30 years of knowing that everyone you loved on Earth is either dead or utterly beyond reach, that the world you left has had 30 years to change without you, and the world you will return to is not the world you remember. And then you have to go back. 30 more years. The rocket equation, the Shilkovsky rocket equation, is one of the most unforgiving relationships in physics. It describes how much the mass of your fuel must dwarf the mass of everything else you want to move. Every kilogram of payload requires not 1 kilogram of fuel, but several, because you need fuel to carry the fuel, and fuel to carry that, and fuel to carry that. The exponential compounds. The fuel fraction of any practical interstellar ship becomes, at some point, the entire ship, leaving no room for the thing you actually wanted to move. Engineers call it the tyranny of the rocket equation. They are not being dramatic. For 63 light years at any propulsion speed currently imaginable, the fuel requirements are not merely challenging. They are beyond the capability of anything we could build. The ship required to make this journey is not a bigger version of anything we have made. It is a different category of object, something that does not yet exist in engineering, only in mathematics. But the fuel is almost beside the point when you consider the state of the crew. A crew that has spent 30 years reaching this planet and now faces 30 more years of return is not the same crew that departed. The damage mechanisms do not add, they multiply. Compromised bones mean higher injury risk during any emergency maneuver, and a 60-year voyage will have emergencies. A dysregulated immune system means greater vulnerability to the reactivating viruses that have been dormant but building, and at year 30, those viruses have had 30 years to build. Declining cognition means greater probability of errors during the crises that inevitably occur over 60 continuous years of spaceflight. Navigation errors, maintenance failures, medical misjudgments, equipment operated incorrectly because the person operating it is no longer operating at full capacity. A 60-year mission is not 2 30-year missions laid end to end. It is something exponentially harder because the ship ages, the crew ages, the margins shrink. The redundancies that were designed to handle one failure begin to handle 2 or 3 simultaneously, and the resources that were generous for 30 years become tight for 60. If the crew returns at all, they return at 85 years old. If they were 25 when they left and somehow survived, they would have spent every single year of their adult lives in space. Every year, from 25 to 85, 60 years of a human life, which is most of a human life, spent in a metal tube traveling through the dark. They would arrive at a planet that shares their DNA, but is otherwise unrecognizable. Their friends are dead. Their families are dead. 60 years of culture, technology, politics, language, and music have accumulated without them. The names on the news are not names they know. The institutions they remembered may not exist. The cities look different. The slang is incomprehensible. They are not returning home. They are arriving somewhere that was once home 60 years ago and has continued without them in the way that everything continues without everything that is absent long enough. And their bodies, adapted over 60 years to microgravity, would be asked to stand in Earth's gravity field again. Their cardiovascular systems would be asked to push blood upward against a force they have not experienced in 6 decades. Their leg muscles would be asked to carry weight they have not carried since middle age in a body that is now elderly and compromised. Some of them might not walk again. Some might not survive readaptation. The shock of returning to Earth after 60 years in microgravity is not something we have data on because no human being has ever done it. But everything we know about shorter missions, extrapolated with careful conservatism, does not suggest a gentle landing. This is the cost of the round trip. This is what the physics offers. You might think, and this is a human thing to think, a generous thing, that technology will change this, that in 200 years, or 500, we will have propulsion systems that close the distance, shields that stop the radiation, medicine that prevents the deterioration. You are probably right, in the very long term. But here is what is different about HD 189733b specifically. Even if you solve the journey entirely, even if you arrived with a crew in perfect physical condition, having spent weeks rather than decades in transit, you still cannot land. Not because of any technological limitation, because of what the planet is. There is no surface. A human being cannot stand on a gas giant. Any descent vehicle faces pressures and temperatures that exceed the limits of any material we can make or theoretically conceive. The winds destroy hardware. The radiation environment near the host star is severe enough to erode the planet's own atmosphere. Even robotic probes would survive in the atmosphere for minutes, perhaps hours, before being destroyed. HD 189733b is not an engineering problem. It is a physics reality. The Juno probe at Jupiter, built to survive the most intense radiation environment in our solar system, has a deliberately limited operational lifespan because of radiation damage. And Jupiter is inside our own solar system in a far milder stellar environment than HD 189733b's. You could spend $1 trillion and a century of engineering. You could solve every problem of propulsion, radiation shielding, and medical intervention. You would still be in orbit around a planet you cannot enter, made of materials that cannot exist in any configuration compatible with a human body, driven by a physics that does not acknowledge your ambitions. These are not challenges waiting for solutions. They are constraints set by the nature of reality. And perhaps the most quietly sad thing of all is this. We can know HD 189733b deeply. Spectroscopy lets us read its atmospheric chemistry across 63 light-years. Hubble measured its color. We know about the iron rain, the silicate clouds, the wind speeds, the temperatures. We know more about this planet than explorers of previous centuries knew about continents they could reach by sailing ship. We can know it. We just cannot touch it. We cannot be present in it. We cannot know what it is like to exist there in the way that only physical presence can provide. HD 189733b will never know human footprints, not because we haven't tried, not because we aren't clever enough, because the universe was not built for us. It produced this blue world of iron rain and glass clouds and unbreakable winds, and it also produced us, small and fragile and relentlessly curious, living on our one small planet, looking outward. There is a line of thinking, in Stoicism, in Buddhist philosophy, in the reflections of astronauts returning from orbit, that the acknowledgement of your own smallness is not defeat. It is a kind of liberation, the recognition that you are not the measure of the universe, that the universe was not assembled with you as its reference point, is not a wound. It is a clarification, a clearing of the field. When you look at HD 189733b, really look at it not as a data point, but as what it actually is, a world of unimaginable violence and beauty existing completely independent of any human awareness or need. Something clarifies. We are small. We are adapted to a very specific slice of the universe's enormous range of conditions. We need temperatures between roughly -40 and +50 degrees Celsius. We need 21% oxygen, mostly nitrogen, no sulfuric acid, no methane at high concentrations, no chlorine. We need liquid water in reliable, accessible quantities. We need gravity approximately like Earth's. We need a star at a very specific distance, stable for billions of years, neither too active nor too dim. We need a magnetic field strong enough to deflect most cosmic radiation. We need an atmosphere thick enough to absorb the rest. Every one of these requirements narrows the universe's acceptable environments for us. Multiply them together, and what remains is a very specific kind of place. One we have found, as far as we know, in exactly one location in the observable universe. Earth, not Mars. It lacks the magnetic field, the thick atmosphere, the liquid water, the stable temperature range. Not Venus. Venus has the temperature and pressure of HD 189733b at a distance we could actually reach. Not the Moon, not Europa, not Titan, not Ganymede. Earth. And certainly not HD 189733b, 63 light-years away. Iron falls from clouds of vaporized metal in an atmosphere the temperature of stellar surfaces. It has been falling since before the first complex life appeared on Earth. It fell while the dinosaurs walked, and while the first primates climbed trees, and while the first human beings looked up at the stars and wondered what they were. It will fall long after the last human being is gone. It does not know we exist. It does not care. It is not beautiful for our benefit and not terrible for our punishment. It is simply what physics produces when you place a Jupiter-mass planet 12 times closer to a star than Mercury is to our sun. It is not personal. Nothing in the universe is personal. That is perhaps the most difficult and most clarifying thing about it. The universe is not hostile. Hostility implies intent. The universe is indifferent, which is something more profound and more humbling than hostility. You cannot fight indifference. You cannot negotiate with it. You cannot overcome it with courage, or love, or creativity, or the sheer stubborn refusal to accept that something is impossible. Physics does not accept stubbornness as a variable. You can only recognize indifference, clearly, honestly, without flinching, and in that recognition, find something valuable. What you find, if you are paying attention, is this. The universe's indifference makes Earth's hospitality not the default condition of the cosmos, but the rarest and most precious exception to it. Every sunrise is not guaranteed. Every breath of breathable air is not a given. Every glass of liquid water is not inevitable. Every temperate day, every season that cycles properly, every rain that does not dissolve metal, every wind that does not exceed the speed of sound, all of it is the product of specific and fragile conditions that happen to exist in exactly one place we know of. We did not build this world. We inherited it. We evolved to fit it, and it evolved with us. Or rather, life evolved to fit Earth across 4 billion years of trial and error and extinction and adaptation, and we are the latest and most complicated product of that negotiation. The Earth shaped us. We are, in the most literal biochemical sense, a product of this specific planet, of its gravity, its atmosphere, its temperature range, its water cycle, its magnetic field. Remove any one of those parameters significantly, and the chemistry that makes you begins to fail. HD 189733b reminds us of this, not in a comfortable way, not in a life-affirming poster way, in the way that the void reminds you what air means, in the way that 4,000 degrees Celsius reminds you what temperature means, in the way that iron rain reminds you what water means, in the way that 63 light-years reminds you what home means. 63 light-years away, a blue planet the size of Jupiter is raining iron right now. It has been raining iron for 4 billion years. It will still be raining iron long after the sun swells into a red giant and swallows the Earth, long after the last star in the Milky Way burns out and the universe has grown cold and dark, and the photons crossing it carry no message anyone will ever read. And here you are, warm, breathing, on the only planet in the known universe that knows how to keep you that way. Go outside tonight. Look up. You do not need to find Vulpecula. Any piece of the sky will do. 63 light-years away, invisible, unreachable, beautiful, lethal. A blue world is burning. The iron is falling. The winds are blowing at 2,000 kilometers per hour through clouds of glass in an atmosphere the temperature of stars. And here, the temperature is somewhere between 10 and 30 degrees. You can breathe without a suit. You can feel the ground beneath your feet. You can hear the wind, and it is not supersonic. The universe did not give you this. A random accident of planetary formation 4.5 billion years ago gave you this. You are not owed it. You were not promised it. You simply, improbably, beautifully are here. That is not a small thing. That is perhaps the largest thing there is. We did not land. We could not land. We were never meant to land. HD 189733b is humanity's worst nightmare, not because it is unusual in the galaxy. Hot Jupiters are common. It is humanity's worst nightmare because it is a perfect intersection of every category of hostility: distance, temperature, pressure, wind, radiation, the absence of any surface, the absence of any chemistry compatible with life. All of them at once, all of them at their extremes. It is beautiful. That deep cobalt blue is real, measured by Hubble, confirmed by science. From 63 light-years, it hangs in the darkness like something from a dream. And there is something genuinely moving about its existence, about the fact that it was always there, raining iron in the dark, long before we had telescopes to see it, long before there was a we at all. The universe is very old. We are very new. And in our newness, we have looked up and found things that dwarf us in every conceivable dimension. The appropriate response is not despair. The appropriate response is wonder and honesty, especially the honesty to acknowledge when a place is physically, irrevocably beyond us, not beyond our dreams, not beyond our curiosity, but beyond our bodies. Our bodies do not belong in the atmosphere of HD 189733b. They belong here, on Earth, in the narrow band of conditions that built them. This is not a prison. This is a home. The difference, perhaps, is everything. I hope you enjoyed this video. If you did, a like and subscribe would really help the channel. I'll see you next time.